Hello everyone, my name is Eddie Yang, and today we will be talking about an interesting problem that I got assigned. Let's work through it. The problem states how many 5-digit positive integers exist where the digits are non-increasing from left to right. Non-increasing means that repeats are allowed. For example, 7, 7, and 4 zeros in a row are allowed per the examples. And obviously, 78 and 78,000 is not allowed since 8 is larger than 7. If you would like to solve this problem for yourself, feel free to pause the video now and try it out. When I first saw this problem, I immediately thought to bash it out. So I know that there's 9 choices for the first number, 1 through 9, and for each choice, there's X amount of choices for the second number, and then for the third number, so on and so forth. However, this solution is very, very time consuming, and it's very easy to mess up one of the calculations along the way. That's why I tried to find a more elegant solution that would take me less time and be harder to mess up. So for this solution, let's take a look at our example, 87,743. So we'll work with this number. For my solution, I split up this number into 5 separate numbers: 8, 7, 7, 4, and 3. Now, you'll notice that looking at these 5 numbers, the only way we can order them to satisfy our conditions would be the number 87,743. This is because the largest number, in this case 8, has to be first. The second largest number, 7, has to be second. It doesn't actually matter which 7 we choose, since it will result in the same number anyways. So this is our key insight. We have now realized that for any set of 5 numbers, repeats allowed, that we take from 0 through 9, that will map to one single 5-digit positive integer that satisfies our conditions. Now, our logic seems sound, but we have to check for edge cases, and in fact, there is one. Our logic can create the number 00000, and no matter how hard you try, this number will always be 0, which is not in fact a 5-digit positive integer. This means that whatever number we get in the end when we solve this problem, we have to subtract 1 for our edge case of 5 different zeros. Now, I'm writing it over here so that when we're checking over our work, we will remember and we will check that we have actually subtracted 1 from our final number. So let's get to solving this problem. Per our logic, we have to find the number of sets, repeats allowed, of 5 numbers out of the 10 numbers 0 through 9, and it doesn't matter which order we choose our 5 numbers. Repeats are allowed, and order doesn't matter. This is a classic stars and bars problem. If you don't know what stars and bars is, AOPS offers some amazing books on combinatorics that covers stars and bars, in addition to books that covers general topics in competition math. In addition, I highly recommend Po-Shen Loh Live, which is an online interactive course that you can take that covers topics such as stars and bars, as well as unique skills that you will need to thrive in competition math. So let's get to applying our stars and bars. We have 10 different numbers, so we can separate these numbers into slots, each slot representing a number, and we can separate these slots using 9 bars. So here I'll make 9 bars, 1, 2, 3, 4, 5, 6, 7, 8, 9. And each slot, separated by these bars, represents one of the numbers from 0 through 9. I'm just writing out the numbers here, so it is easier for you guys at home to see my logic. 6, 7. Okay, so you're thinking, cool, you have 10 different slots. How is this going to help us get our set of 5 numbers? Well, we can actually put different dots or stars into these slots to represent each of our numbers. So in this case, we will have 1 star in the 8 slot, 2 stars in the 7 slot, 1 star in the 4 slot, and 1 star in the 3 slot. Now notice that any permutation of 5 stars and 9 bars will get a different set of 5 numbers. And as we said previously, each set maps to one single solution to our problem. So now this has just become a very simple combinatorics problem, as now this is just 14 total spots that we are choosing 5 different stars to put. So this is just 14 choose 5. Now 14 choose 5 can be written as 14 factorial over 9 factorial over 9 factorial times 5 factorial times 5 factorial. And this turns out to be 2002. Now, you might think that we are done. However, remember that we had that edge case up here. And because of the edge case of 0, we have to subtract 1 from this answer, meaning that our final answer is actually 2001. And we're done. Thank you, and I hope you liked my solution. If you did, please feel free to drop a like. If you didn't like my solution, please feel free to drop a dislike and tell me in the comments what solution you would have used to solve this problem. Thank you.